My name is Nienke Bierhuizen. I'm a teacher in psychology and a researcher in brain-computer interfaces. A brain-computer interface is an interaction between a computer and a human user by measuring physiological data, such as, for example, brain activities, and giving direct feedback. The BCI testbed is a consortium with the UT and 4 industrial partners, VD-Nexus, Thales, Artinus and Nodus, and we study non-medical applications of brain-computer interfaces. When you are building a brain-computer interface, you have to follow different steps. The first step is signal acquisition. So the measurement of the physiological data from the user. The second step is pre-processing. Then you're doing feature extraction to select the features of the brain that you need for the application. And lastly, you have to translate those features for your application. At the BCI testbed, we conduct different experiments with the aim of measuring psychological constructs with physiological sensors, such as EEG, fNIRS, heart rate, or skin response. So my study is a bit more fundamental. I am interested in trust of both human and AI team members. I am measuring trust of faces and devices by measuring EEG signals compared with a memory task. I'm using 2 theories to substantiate my design. So the first theory is called the cheater detection mechanism, and it suggests that we can better remember people that we do not trust. So you can imagine from an evolutionary point of view that if you have encountered someone and you didn't have a good experience with someone, that you will remember that during the second or third encounter. The second theory is about brain activity. The M effect is an effect that is measured when you first look at a stimulus, so for example a face. So I am combining these 2 theories to measure the relationship between trustworthiness and memory for both faces and devices. I'm interested whether we can predict trust and memory by measuring the brain activity during the first encounter. So my experiment involves 2 sessions. The first session is an EEG session, and the second session is done by the participant online at home, and this is just a questionnaire. During the first experiment, I start applying the EEG, and actually the application of the EEG takes the most time because my experiment itself is very short. I will ask people to watch the screen while they see pictures of faces and devices, and their only task is to click T if they think it's trustworthy, or U when they think the faces or devices are untrustworthy. And then after 125 images, the experiment is done and I can get the EEG cap off the participant again. And that will end the first session. The participants can wash their hair, and then 48 hours later I will ask them to fill in the questionnaire for the second session. So in the second questionnaire there are 200 images of faces and devices. A part of those images they have already seen in the first experiment, but there are also images that are new. So for each image they again have to label them trustworthy or untrustworthy, but they also have to label the images new or old. I expect to find that the pictures that the people labeled as untrustworthy will be remembered better. And of course, I hope to find that there is a difference in brain activity between the images that were labeled as trustworthy and untrustworthy and the pictures that were remembered and forgotten. Because if I can find this also means that I can use it to predict trust and memory when you are using brain activity during the first encounter of a stimulus. So hopefully this study, together with the other studies conducted in the BCI testbed, will later really improve complex working environments where people have to work with computers together as team members.